We spent 4 lessons building structure: the couplet, the relation, the clan. Now we turn to action, to the verbs of the algebra, the operations. Here is the beautiful part, and the whole reason we bothered with a tower. You do not learn a separate set of operations for tables, another for documents, another for graphs. You learn each operation once at the bottom, and it lifts unchanged to every level above. This lesson covers the operations you already half know from ordinary mathematics. The next lesson covers the few new ones that the algebra adds of its own. Think about what an operation actually is. It is a rule that takes one or two things and produces another of the same kind. The magic of the tower is that a rule defined on couplets automatically makes sense on relations, which are sets of couplets, and on clans, which are sets of those, and so on up. Define transpose once, and it works everywhere. This is why, although the algebra has 23 operators in total, in practice there is far less to learn than that number suggests. Most of them are the same handful of ideas lifted up the tower. Start with the simplest verb of all, transpose. A couplet is a directed pair, A arrow B. To transpose it, you just reverse the arrow, B arrow A. That's the whole operation. Now apply it to every couplet in a relation, and the entire relation reverses direction at once. Why care? Because a relation that maps names to phone numbers, transposed, maps phone numbers back to names. A lookup becomes a reverse lookup with a single operation and no new code. Small as it is, transpose is a genuine algebraic operator with clean, dependable behavior. Now the operations you have known since school, because relations and clans are at bottom just sets. The union of two relations is everything in either of them. The intersection is only what appears in both. The difference is what's in the first, but not the second. There is nothing to relearn here. It is exactly the set theory you already trust, now doing useful work on data. Combine two result sets, find their overlap, subtract one from another. Do it all with operators whose behavior never surprises you. Let me gather this lesson onto a single card. Transpose, which reverses couplets. Composition, which we'll lean on heavily later. If one couplet points A to B and another points B to C, composition follows the chain to give A to C, which is precisely how you traverse a graph. And the four set operations: union, intersection, difference, and symmetric difference. If you are not familiar with symmetric difference, it refers to the items that are in one set or the other, but not both. That's 6 verbs, each defined once, each with clean algebraic properties, each working identically whether you point it at a relation, a clan, or an entire database. Here's the tower yet again. Every operation you just met is defined at the foot of the tower and lifts, without change, all the way up. Union of two relations, union of two clans, union of two hordes. Same idea, same behavior. You do not carry a different toolbox for each kind of data. You carry one small toolbox, and the tower guarantees it fits every level. That is the leverage the algebra was built to give you, and it is why a single engine can do the work of a whole shelf of specialized databases. So to summarize, Transpose reverses a couplet, and composition follows one arrow into the next, which is graph traversal in disguise. The set operations, union, intersection, and difference, come straight from set theory and need no relearning. And every one of these verbs is defined a single time and works, unchanged, at every level of the tower. That's the familiar half of the algebra's vocabulary. In the next lesson, we meet the operators the algebra adds of its own, the ones that give you selection and at last the join. That's the first half of the verbs, the ones you already knew, but working on data. Thank you for your time. In lesson 6, we meet some new operators.